Go ahead and,
Okay.
okay, so hey, I'm here with Ron Oak. Olk, did I pronounce that
Olch.
correct? Olch.
Olch.
Olch. Like it's like a TCH, Olch.
No, CH. Olch.
But I'm gonna pronounce it like a TCH because that helps me. Okay.
Yeah,
In my mind, I will think of it that way.
that's fine.
And you are in what position relative? What's your affiliation with UFO Data Acquisition Project or UFO DAP?
I'm it.
Okay, so you are UFO DAP.
I am the chief cook and bottle washer.
Okay, and is it a nonprofit?
No.
Is it a for-profit?
Yes. It's I in order to run it correctly as a proper business in California, I established a single owner LLC.
That's an LLC.
Yeah.
Okay,
So
great.
then I got to pay for that every year, and but basically I do this in order to produce systems that have the appropriate characteristics and are sustainable and high quality and can survive outside and all that kind of stuff. But I don't try to make a whole lot of money, but enough to keep the business going properly, pay the taxes and whatever I have to do. But it's really something I started, about 8 years ago in 2014. And, and here we are.
Yeah. It's okay to be a for-profit. I just want to record correctly what you're doing,
Mm-hmm.
So you started in 2014.
Yeah, I built a prototype, using a kind of low-level components, trying to do the whole thing on an embedded Raspberry Pi. And I built my own like little pan tilt head out of, typical servo components and put a,
Sorry.
yeah,
So just for our audience, because we don't know who's watching, Raspberry Pi is a method of interacting with a circuit board so that you can run programs on the circuit board, whatever you want.
yeah,
to do.
it's like the extremely well-known, popular Linux-based little microcomputer, and it was created by folks in England because of the rise of cell phones, and the CPU chips that became available from that gave some very powerful, very low cost computer. So, and then is Linux, so there's a huge base of knowledge of the operating system that was then adapted for it and so on. So took advantage of that and all the free software development tools. All the software I do is written in Python. And there's a whole bunch of libraries which are essential to doing any code in Python, practically, that I use. In particular, one's called OpenCV, which I use for all of the most not all of the image processing tasks.
Okay, but I'm gonna slow you down here because not everyone, including me at this moment, really understands the purpose of UFO DAP. So you're talking about all these data gathering methods, and I think that's the purpose of UFO DAP, but maybe you could define it more clearly.
I've been involved with UFO subject and research since the 1970s, where I got involved into a thing called the LA UFO Research Group. We founded at UCLA back in the day. And we've met almost every month since then, amazingly. In fact, we've got one tomorrow.
Cool.
A small group that remains. And so, but each person had kind of their own interest or direction. And mine, of course, from my background in engineering and electronic systems and software, was data collection, and collecting instrumental data when possible. But of course, and there have been some efforts to do that over the years, and not several of them if you look into it, but they resulted typically in really big, expensive one-off collections of stuff that were irreproducible, and it also meant that they could only be in one place at a time, and that they would only live there in that place for a limited period of time. And most of them were not environmentally sound. So, I think the Hesdalen project put up some stuff on one location up on a pole, and I guess it survives the weather, bad as it is.
So almost like hobbyist, almost like each hobbyist would have their own collection of data collecting tools. Is that right?
Hobbyist?
I mean, almost like the hobbyist movement where this is my stuff and I think this is going to work, and then someone else has their stuff.
Well, some of these were from, small groups or very dedicated individuals. They had to come up with a whole lot of money to get all that equipment back in, in the 70s, 80s, and so on. So it was just not the way to go. So it turned out that around 2014, when I got into this, it got to the point where the cameras, the software tools, the computer, and PC availability and low cost of very powerful PCs, all these things came together to allow me to produce a system that would solve these problems, which I describe in my presentation as CU.
Well, wait, where can we find that presentation if we're,
Yeah, right, on ufodap.com.
and is it obvious from the front page how to get to it?
Pretty much, yeah. Mhm.
Okay, so it's your SCU 2022 presentation?
Correct.
Okay,
And what it is, it's about 30, 40 slides with me, describing them in vocally.
I saw that. I thought it was excellent, but one thing that I hoping that you could state for the audience here is what kind of UAP data does this collection of sensors actually look for?
So the concept is, in terms of what was, I'm always UFODAP is balancing cost performance. What can we do that has the environmental characteristics, but also, and can collect data that's scientifically valid.
What do you mean by environmental characteristics?
Well, in order to, as I mentioned before, the prior systems weren't outside where you could actually collect real data 24/7, 365.
Do you mean so they need to be ruggedized?
They're ruggedized, they're IPs like IP66 or 67. It means they survive rain, snow, sleet, high temperatures, low temperatures, right? Because in fact, I have one that's the first one that really was in place was in the San Luis Valley. It's out on a ranch on the top of a building. It's shown in the scroll of video at the very top of the homepage. You can see there's an owl we put next to it to scare away the birds. So they went poop on that dome on the camera, which worked pretty good. But anyway, that's been there for more than 2 years, continuously operating. I haven't been collecting data from it all the time, but I know the camera works.
So you've got visual data, or is that an infrared camera?
So what we have is two different kinds of data. One is visual data in the normal optical spectrum.
Like moving data or stills?
Video. This
Okay.
is real time. These are based on IP cameras or USB cameras even, or pan-tilt zoom IP cameras.
Okay, so real-time video in the optical spectrum, that's one kind of data.
Right. And the different kinds of cameras, they might provide a fixed field, fixed optical field camera, or they might be a pan-tilt zoom, which moves, 0 to 90 up and down in elevation, or 0 to 365 all the way around.
Is it driven by tracking software?
And so the camera is connected through as an IP internet, or either locally on the LAN of the PC running the software, or like the one in the San Luis Valley, all the way over the internet, 1,000 miles away, and I can run it on my computer. And on the computer is software, one of two major pieces of software called OTDAU, or Optical Tracking Data Acquisition Unit. And so the architecture is that there are different kinds of data acquisition units. One type is optical. The optical tracking data acquisition unit software has a myriad of functions to, first of all, interface to the camera, and then monitor that image. Typically you start out with looking up at a fixed part of the sky, and it's waiting there, scanning for anything that's moving within certain parameters. Is not too big, too small, and so on, and how fast it's going, and many things. But once it locks on with the detection, it continues in a tracking mode, and no matter where that object goes, whether it's a fixed camera and it follows it across the field of view, or if it's a pan-tilt zoom, it has the capability, this is the really hard part, of continuously trying to move the image of the object toward the center of field of view, and the reason for that is so that it can incrementally zoom in on the object. Because as you can imagine, if you try to zoom in and you're not at the center field of view, the object will go shooting off to the edge as you zoom in. So because it has closing a servo loop in effect,
Mhm.
PID loop on the object by the error from between the position of the object and the center field of view. It's
Mhm.
continuously moving with the object no matter where the object goes. And a 0 to 90 360 camera doesn't matter where it goes, up, down, left, it'll track it till it goes out of view.
Yeah, but if it gets pretty zoomed in and the object decides to zip out, then you're,
Then it disappears. And what happens is it automatically detects that and zooms back to its home position that you define.
circles back. Yeah.
And it zooms back and it starts over. And it does that forever. In fact, with various other parameters like time of day, one can say, well, it makes no sense to try to do that in the morning when all the birds are flying around, or whatever one wants. It also has the means of setting up what's called a tour, where one can define up to 16 different azimuth and elevation and zoom even, and how long to dwell at that position. And it will move to each of those tour positions one at a time and stay there for as long as the time is set to, and they're all individual. So you can actually take a PTZ camera and look at the whole sky with it, but incrementally. Yeah, the other way to do that is it also supports what are called all sky cameras, which typically used for meteor hunting, for example, where one camera with a special lens that looks, the entire sky from, and you may have seen these like a circular image of everything.
Sure.
The issue, though, of course, the difference is the size of potentially trackable objects are very tiny. It will detect them, and it get bigger, and because it's distorted, they get bigger and maximum at the azimuth, at the peak right over the center. But the software actually rectilinearizes that image so that it can do another trick of the software.
So it's even scaling right at the foveal, right at the center point?
Yeah. So what happens is you lose the periphery, but you get a flattened image. And the reason for doing that is so it can accurately calculate where that image is in the frame, so that it can, in what's called a handoff mode, it can have a second camera on the system at the same time, and in particularly a pan tilt zoom camera. What it does is it says, oh, I see an object here. Okay, tells the pan tilt zoom, you zoom pan tilt over to roughly point the camera at where I think it is, and then I'm going to hand off control, and now the pan tilt zoom camera makes its own detection and continues to track and zoom as if it was the only camera in the system. So it's a combination of a continuous all sky view, but when you see something, now I have the ability to incrementally zoom. And the really important thing about that was lost on people before, I think, is that when you have a relatively low resolution camera, even say 1920 by 1080, but you can zoom in 30 times, the number of pixels on target is as if you have a really amazing super high resolution camera.
Right. You're basically boosting the resolution by zooming in.
Right.
It's a bit like having a lazy eye. This approach you're talking about, where one eye could go, oh wait, I'm going to go look at that.
Yeah. So that's something that so the OTDAU software has the ability to combine.
Can you say the name of it slower?
Pardon?
The OTD, the name slower. Say the name slower.
Optical Tracking Data Acquisition Unit.
Thanks.
OTDAU. And of course, it's all described. There's lots of examples on the website, shows it tracking things and all that sort of thing.
Question though, so is this all necessarily visual frequencies, or could this be infrared or?
Well, where I'm heading with this, I have a number of development projects in the works so this is a continuously evolving thing. And so the next thing I want to do in terms of tracking is I've investigated a independent pan tilt head, which in other words, it's a box with a platform on top that can tilt and rotate, but it has no dedicated cameras, but it has two platforms, one on each side, that rotate and tilt. So on one side, for example, I can mount anything on either of these, but one side might be, say, a fixed wide field camera, and the other side might be, say, an IR camera.
Right, and then you can superimpose them.
So what happens is you start out in it, the wide field camera it's using for its initial identification and subsequent tracking. And when
Mhm.
that camera sees something in the optical an EO camera,
Mhm.
electro-optical spectrum, it
Mhm.
will track it, but all the while recording both
Both
cameras.
channels, right? And so
Right.
then you can have an algorithm that looks at them and sees, do I see something here where I don't see it here, et
Right.
cetera.
So it can be
Yeah.
recording simultaneously in EO and IR.
That's
Or
cool.
the other side might be a radar or anything you can think of.
Yeah, right. Okay, a couple questions about this. So, could there be, so what I'm gathering, and let me know if I've got this wrong, is that you're creating these different kinds of creative sensors specifically for looking for UAPs and trying to understand them, and that individuals buy the equipment like as a unit from you, and people can do sort of different algorithms, create different algorithms for how they're going to search. Is
Well,
that the
they don't
idea?
create it. No, I created all the algorithms.
Oh, but I mean, I'm sorry, they're setting variables.
Right. Well,
Okay.
there are variables they can tweak and adjust for the optical conditions at hand or whatever else they want. There's all kinds of stuff like that.
So the idea is sort of a shotgun approach. If you get enough people who are setting things that are taking these from a bunch of places and setting them with interesting
right
parameter settings, maybe you get something.
right and on the website there's I think the sites tab. Today there are more than 40 sites worldwide. That is to say, individuals who have purchased systems of all kinds. Some are much more complicated and expensive, and a lot of them they just bought the software. And one reason they did that is because they provided their own camera. Some
Right.
even built their own mount.
Right.
I mean, there's all combinations of, and that's part of the beauty of the thing, that it's a very flexible architecture that
Do
lets
you get the data, or do they own the data and you never
they
see it?
own the data. That's a critical thing. Other projects had taken the approach that, oh, you just buy the hardware and set it up and plug it in and don't worry about it.
Right.
We'll suck out all the data all the time. You know? And I found that people really don't like that, especially when they put a lot of money into it.
Yeah, they want the data to play with.
They want the data and they're chomping at the bit to share it with us,
Yeah.
which is another big aspect of UFODAP, which is
Mhm.
yet to be realized, which we're working on with in our collaboration with the SCU and particularly the UFO data group.
Yeah, of SCU.
Yeah.
Yeah.
And UFO data, I don't know if they're on your list to talk to.
Just the SCU in general.
Yeah. Well, there's this UFO data is also allied with SCU.
Oh, UFO data is its own organization. I misunderstood. I thought it was a SCU project. Okay, got it.
Right. Totally like UFODAP. It's headed by Mark Rodiger.
Oh, I did talk to Mark Rodiger. We mostly talk about KUFOS, but a little bit about UFO data.
Perfect.
Yeah.
Well, his big deal is, and we had this alliance for a couple of years now. They're attempting, and they haven't got there yet, to build the software to create an online database so that users of UFODAP stuff can upload interesting stuff with text and photos and videos, whatever they collected. And UFODAP, collects CSV files of camera positions and all kinds of other stuff, and not
To
just
upload everything to the UFO data people.
Pardon?
So the idea is that people who buy the UFO DAP system can upload all their CSV files to the UFO data.
So I'll upload this to the UFO data folks who would provide the expertise, the stable of expertise, along with the SCU, which has the people to do this, the interested folks they're going to run their own system or collect their own data, but they're really, hopefully know what they're looking at or want to obtain an understanding. And ultimately, what we all want to do is take all that data and review it and publish it. And that's the net goal. The end item of this whole thing is is create publishable scientific research and data. And so what I do, what UFODAP goal is create the tools for citizen scientists, if you will, to collect the data to begin with in a effective way that never existed before.
Oh, right.
Okay, but all the things I've described about the optical part, that's only half of it.
Well, hold on a second.
Yeah.
We have now answered one question, and beautifully so. So the goal of UFODAP is to create tools for citizen scientists to collect the data to begin with in an effective way that never existed before. So that's beautiful.
Right.
Question. Have you tried the idea of having one, or maybe you've already done this, one centralized UFODAP, maybe it's on your house, that citizen scientists they get a certain day and they get to set the parameters for that day, so that it's one location, but the parameters are being set differently over time. And over time, maybe you see what parameters are most helpful for that location just by
Well,
different people setting them.
I don't think it would be, and it probably would never work to have different people trying to use somebody else's camera or something like that. There are a couple cameras, right, installations right now where the individual, and this was encouraged by me or whatever, they don't, there's not very many out of that 40, but there's a few where they've installed the camera on, say, the peak of the roof of their house in a really good, potentially interesting place, but they don't want to run the software. So what can be done is the camera and all the installations have to do this. The cameras end up into their router. Okay. Then they port forward the port of the camera to their wide area network address. And then somebody like me from a great distance away can operate that camera with the OTDAU software as if, and just like they would be doing if it was on their own computer.
Got it. So it's sort of backwards of what I
data.
was saying. Yeah.
Yeah. Well, so it's kind of the in between. They don't. They may be doing this because they like the idea of providing a location for the instrument, but they have no interest in tending it or running the software or anything. And that's part of the architecture.
And that works fine. You could do that because of the IP. Yeah.
Yeah. So
Awesome.
all combinations.
Okay. So here's something. What would your organization, I mean, I know you're not doing the data analysis. You're partnering with SCU and UFO Data Project to do the analysis of the data, but just you, since you are your organization, what would you consider to be a good or excellent evidence based on the data from UFO DAP for an unidentified aerial or submersible phenomenon?
Well, that is a real, the ultimate question, and that's something that there's been a lot of discussion within the SCU. I know Robert Powell has some particular ideas. In fact, the SCU is waiting, for something, I guess, for a little bit more information, maybe. Anyway, they would like to buy their own equipment and set it up, and the composition of those systems based on answering that question. So, for example,
but for you, forget about what the ICU thinks. For you.
But again, I'm just providing systems so scientists and groups like the SCU can use them. But it's important that they wrap their heads around and decide on the parameters they want to use them. Just for example, a really good idea that I think they've had, what Robert says, well, a good characteristic of a true UFO is not just a fixed light in the sky, but that light has to move in such a way, that it is a characteristic of a non-ordinary object, like a right angle turn at high speeds, and
it's the dynamics.
It might also be the spectrum of light it produces, and changes during that movement, which is one thing you'll see. By the way, in the UFO DAP development, I developed an optical grating that fits in front of a camera, and it actually can detect and track an object while recording the optical spectra as a line spectra that moves with the object in real time. And
oh, cool. So it's like a 3D spectrogram. You've got time, you've got frequency, and you've got position.
Yeah. In fact, I just reached over to show you what that looks like.
Can you share your screen? Oh, you've got that.
Yeah, this thing, and it has these three little dots are magnets buried in this plastic assembly with a good grating in the middle, and this snaps by magnets onto the front of the camera. A pan tilt zoom video camera.
Yeah,
it's on top of.
Yeah, that's cool.
And so it not only it gets the spectrum, but it's happening in real time. And while the object is moving, so the objective, because of what we're doing, our particular case, we want to see it's known in the literature, an object might have a fixed kind of spectral light coming in, but all of a sudden it sort of powers up, getting ready, and then moves quickly away. We definitely want to record that change.
Well, it's a signature.
And that signature answers your question.
Yeah, it does.
that's the kind of thing that would indicate, gee, that's really strange. That's not an aircraft, it's not a star, you know, and so on.
Yeah, you're looking for a signature that's different from natural
So
and,
it could,
and human-made
right. So it
phenomenon.
could be, right,
Mhm.
motion, intensity, all kinds of things like that, whatever we can, but you
And
know,
that kind of the filter you just showed me, can that go on the whole sky camera?
no, that doesn't make sense for an all sky camera, but it goes on a pan tilt zoom camera that I used for development initially. I might use a different one going forward, and I didn't release this as a I didn't release this to the the UFO DAP shop as a purchasable item. And you can go
Yeah,
on the shop now. There's about 70 different things that you can buy
so you
to
can make your own
either
system.
those whole systems or components. I haven't put this out there yet because I'm not satisfied with the quality of the spectrum yet.
Okay,
And what I might do actually is go from this size grading to a smaller one that goes on the front of a different kind of camera.
well, do you have a polarization filter before the,
It's a grading.
oh, okay,
It's a 300 line grading.
okay.
So anyhow, and there's in fact there's in the website now, I believe I've got a sample of video taken with using it. The problem you'll notice is somebody, if you know about trying to do spectra, I know I'm way not an expert, but I think it's too smeared. I don't think it carries it wouldn't create good enough data for our purposes, I think, yet.
Smeared over space or smeared over time?
Well, the line spectra isn't distinct and sharp, so you
Oh,
can
even at a snapshot, it's just this,
even
the frequencies aren't well separated.
because remember, this is coming from a video camera, not a
Yeah,
high resolution camera or
I
something.
would doubt that it can, I think that's your
Right.
bottleneck.
But here's the thing:
Mhm.
if that's not good enough,
Yeah,
remember I talked about that dual platform pan tilt head?
yeah, you could do the two different,
One
yeah,
side could be that a plain old video camera for tracking, but the other side
yeah,
could be a high quality SLR.
right,
They really with a which is commonly done by
yeah.
by amateur and other astronomers.
And then you put them together, yeah.
And they're pointing at the same place. And I plan to write the software that uses the standard API from like Canon and Nikon, which they make it available for free, to trigger the camera to take a set of photos while it's tracking. Let's say click, 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 as it's tracking it across the sky at whatever rate one wants.
Right, right. That's really cool. I hope you do that. So this makes me wonder, and this is not one of my official questions, but I'm asking you anyway. Have you talked to the folks at the Galileo project about them using, because I know they're spending like $1 million on
I
equipment.
know, yes. Well, it's sad, but they don't seem to have any interest in this.
So they
Yeah,
want to use their own.
I think their approach is, well, if we didn't design and build it, we can't trust what comes out of it. I'm assuming that because we have plenty of contacts. I talk all the time with the folks at SCU and everything, and they have all kinds of contacts. And I know they've asked, and I think they're aware, but they've never reached out to me. They express no interest. They don't buy anything.
Okay, well, you know what?
It's surprising because, like, I spent countless thousands of hours on this software, and then they're trying to do it themselves.
It's not surprising though, because a couple of reasons. One is that's how academia is, but also it's also good. And the reason why I say it's good is because you want different people developing different things in different ways, because we're going to find out what works that way. So,
yeah, sure. Well, that's another way to look at it. And that's, I wish them very well. I mean, I think we're all on the same page here. We're all
on the same page. It is frustrating that they don't at least consult with you, because it seems like they could save a couple of years.
Right.
At least. So
if not the equipment, just philosophy and the methodology and
just what you've learned.
Yeah, I mean, practically speaking, as I mentioned before, the whole purpose of developing UFODAP equipment and software the way it is so that it could be a highly distributed modular system, so that there could be many points of data collection in many places simultaneously.
Right.
It's not what they're doing.
Right. Not so far, yeah. So I think I know the answer to the next question. Let me see if I've got this right. So the next question is, what kinds of explanations for UAP reports and data does your organization tend to examine? And I think the answer is none, because that's not what you do.
exactly.
Okay, got it. Good.
No,
I'm
yeah,
catching
my whole
on.
goal in life is to provide the community with the tools to collect the data.
Right.
This is like, you know, you're an astronomer. You don't build your own telescopes all the time. You go buy it from Meade or whoever makes telescopes because you trust them to make really good telescopes. And you probably have a lot of input to them. You tell them what was good and what was bad, you know,
Sure.
and they try to make it better. And that's exactly what I do.
Do any government agencies trust you to build things?
Me, I have absolutely no contact with any government agency, and I'm sure they. I would be really happy if NASA, and you said this was going to be looked at, then I
We hope
would.
so.
It would be great if they would want to, you know, do something about this or provide input or
Have a
whatever.
conversation.
Yeah, converse anything.
Have a
You know, like
conversation. Yeah,
yeah. I
sure.
mean, get the idea, but maybe the architecture they'd find interesting for anything.
Anything.
But anyway, yeah.
Yeah. Okay, good. Okay, so I know what your organization has focused on in the past. Here's a question about the future. Now that, after 2017 and the discussions in the intelligence community chiming in and the military, mostly the military chiming in, how do you see UFO DAP evolving? What would you like to see it evolve towards? Same stuff, or are there different things you'd like to do? And
Well,
maybe it comes right on with the NASA thing.
yeah. Oh, yeah. Okay. I mean, so like I said, there's all these development projects with different kinds, new sensors, new algorithms of all kinds.
What about underwater sensors?
Possibly. I mean, I haven't been into that yet. That's a very different kind of environment to try to work in, and a different. I haven't been working to any requirements, and I don't really have the skills really to try to attempt that because, but that's a whole other discussion, which is certainly makes sense though to look at that. I mean, if you want to have say out in the put a sensor on the ocean floor off of Catalina and look for something happening there. I mean, that actually was done in a sense by the Expedition X team
The
on one of the
UAPX.
shows.
Yeah.
Yeah, Expedition X purchased a system from me, and they use.
Oh, you mean, is UAPX the same as Expedition X?
Not at all, no.
Okay.
Expedition X came as an offshoot from Expedition Unknown, which is Discovery Channel show, and they've used my equipment in maybe 4 different shows so far. They gave me credit in 2 of them, I think, as far as I know. But they don't use it very effectively. It's not their point. They're an entertainment show.
Right.
But they did have one show where they put the tripod mounted system on a bluff over Catalina, and they looked out on the water down to a boat that they were also on, and they saw some really they claim something shoot up into the sky right when at the same time as they were underwater looking at what a really strange thing happened where they were going under the scuba gear and camera underwater, and all of a sudden there was a bright light and it caused the camera and their equipment to fail right at that moment. And they claim at the same moment, they saw this bright light come out of the water and shoot up, which they captured with UFODAP equipment.
Do you think that whales are, I mean, that sounds like a whale spout mixed with some kind of
No, we didn't look anything like that. No.
Oh, was it nighttime? Could it be bioluminescent algae?
It was, yeah, I think it was at lower light levels.
Yeah.
But anyway, the point is though that
I'm just curious because I think that
I wouldn't take that as being very scientifically evidentiary at all.
No, me neither.
For the show, I mean, they would take images from my cameras that it produces video files, and they would use those in the show, and then they would mark, put text and stuff on top of it that never existed. Can you imagine that? So fine. But from being on that show, I got a lot of other people getting in touch with me because the only way they ever could figure out, learned about it. I mean, it's not like I have a huge amount of publicity. That's not what's happening.
Yeah.
But anyway, I would like to tell you about the whole other half of the data acquisition systems.
Wait a minute. I thought there were the 2 parts. Oh, let's go way back up. You said there were 2 types, and we kind of got obsessed with one type, which was all optical. Right. So what's the other type?
Well, the whole other thing is another type of DAU, data acquisition unit. This is called a multi-sensor data acquisition unit, or MSDAU. Okay, it looks like a little kind of a weatherproof plastic enclosure, about, so big.
Mhm.
And it lives outside 24/7, and it has about a suite of a whole bunch of other sensors, including a number of microelectromechanical semiconductors that measure real-time changes to the electromagnetic field and a gravitational field and RF fields. It has a wideband RF scanner, can go from about 25 megahertz to 6,000 megahertz.
Cool.
Rapidly scan that with an external antenna.
Do you have one of those boxes with you that we can see?
It'll be a little hard for me to hear what. Well, you know what? I'm gonna.
I just want to get a size, but if it's too big to haul
Well,
off the shelf.
I'll point the camera at it.
Oh, cool.
This is what the MSDU. It's got the lid open.
Yeah.
This with a seal, and
Uh,
it looks like that. It has this particular light pattern, meaning it's scanning.
I see.
And in the back of it is mounted this particular pan tilt zoom camera, which happens to be the one that has the so I'll turn it around. So you can see the three magnets that matches the magnets I showed you before on the optical scanner. And this thing, you can see antennas sticking out of this. And inside of this, they're mounted up here on top, which is right there at the moment. There's a GPS puck. So it also has continuous GPS reception. And it takes all this data from about 15 different sensors, composes it into a real-time stream over potentially over the internet, just like the cameras, and sends it to a second major piece of software. That piece of software is called mission control. And the concept with mission control software is it has one large screen and 6 small windows. There can be up to 6 different DAUs it's monitoring all the time. Each of those 6 DAUs, one could be an instance on some computer somewhere, maybe in the same computer, maybe a computer 1,000 miles away, of OTDAU software. And that OTDAU software, as we said, could be looking at 1 or 2 cameras. You can, okay. And then another one of those little 6 windows could be an MSDAU, like we just looked at.
So you could get like 12.
You can look
cameras.
at 6, you could be looking at the result of 12 different cameras, or you could be looking at a combination of, say you have 2, in one site, you might say have 2 cameras separated by some distance, each running on their own instance of OTDAU in the same computer. And it might be, say, 1 MSDAU in the vicinity. Now, what's really important about all that is the MSDAU, and this is answering your question, what are we looking for? It's one thing to capture some interesting looking optical thing, right? But imagine if you capture some fast moving object, but at the same time, there was this instantaneous burst of a change in the magnetic field.
Yeah, so you want to change in the signature that's unusual.
Right. So all of a sudden there's this burst of energy, which caused a change in the magnetometer in the MSDAU, maybe some frequency of energy at some pulse rate picked up by the scanner. And if they're at the same time, imagine what that means. So that's the reason for having an MSDAU, that we're looking in multispectral fashion at the same place at the same time.
Yep.
The other major thing that mission control does, if there are 2 cameras on the system, wherever they are, typically maybe you have two cameras and the user spaced them out a couple hundred feet. He's pointed them up in the same general point of the sky and calibrated it to that direction. It can triangulate the position of a object. So if both OTDAUs trigger, in other words, start detecting and tracking, it's hopefully the same object at the same time as it moves across the sky, mission control calculates the crossing point of the center field of view, because it knows the geolocation of the 2 camera sites, and it knows their azimuth and elevation. So it can calculate the location above the Earth and the altitude and speed and size of the object.
Has this happened with any of the cameras that you have data from?
It hasn't to date. I haven't gotten a report from users yet. This is all a little new, but I have several users with multiple systems that they got it and they intended to do that. In fact, a couple of them actually have, two systems like I showed you, that two MSDAUs each with its own camera. That they get.
Well, do they often, sorry to interrupt, I got excited. Please finish your sentence and then I'll ask.
That's all right. Well, I'll just say they have redundant data from the
Right.
MSDAUs that way, which is all the better,
Which is better. Do the people who tend to do something like that tend to live in areas where they see a lot of UFOs? I mean, is that what's motivating them?
Well, I think most of the sites, that's probably what motivated them. They had their own. They say they might say, well, in my area we see stuff all the time. I really want to collect data on it in an appropriate way.
Yeah.
There's also a guy in Canada who travels the world with an array. Formerly, he had an array of fixed cameras. He'd put them on a bar and he'd point them he'd see something, have to point this big heavy mess at the same direction and try to manually do that. Now he has two of my systems and he's chomping at the bit to put that out in the field and be able to run it for extended periods of time. And remember, these are unattended systems. That's part of the important scientific aspect. You're not waiting to, you can miss something easily because who knows when it would happen,
right?
Or how long it would happen. So you just set it out there and go away.
Yeah.
Now, by the way, OTDAU and Mission Control both have the capability to send an email to up to 3 different addresses when something happens.
So they have some kind of threshold. Is it artificial intelligence based, or is it just some algorithm?
Well, no, not to date. It's just, in other words, if OTDAU, for instance, starts tracking, its various parameters are satisfied that it wants to lock on and try tracking something, then it will it'll trigger, and at that point it will start collecting a myriad of data from one or both cameras, plus a CSV file. These are user selectable things. What files do you want to collect?
And who do you want to send an email to?
Yeah, you can set it up for collecting as little or as, different kinds of data. There's various.
I mean,
and then it sent an email. And so you're sitting there having your coffee and you say, oh, there's an OTDAU alert. And it attaches to the email samples of the files it collected after the event is over.
Oh, cool.
And you can look and say, wow, I better go look at the data on my computer when I get a chance.
Yeah.
It's all there. Hasn't gone.
That's really neat. It's an
Same
automated UFO hunter.
Same thing with Mission Control. Mission Control generates a Google map that has located on it all the devices that are on that it's looking at, up to 6 different points in space, and centers the map on that. And the map is zoomable. You can go look around. And on that same map, it can show the position of aircraft in the vicinity. And it has an option to give you a table of the weather conditions in these vicinities.
Well, if I were in the military and I were testing, secret and interesting aerospace technology, why would I not want to seize these if someone would happen to be near a military base? And you know what I mean? Like, couldn't it become sort of open source intelligence on a secret kind of technology?
Beats me. I mean, you mean if some citizen scientist wants to set something up where,
right? Well, even if not even knowing, not even nefarious, but like, I don't even know it, but I live near a place where this stuff is being tested, and I'm like, look at this in the sky, and could that be an issue?
I kind of doubt it, because I mean the military is not going to fly something around thinking, oh, if somebody just physically sees it or receives it on their radio or records it on their cell phone, that's going to be somehow different to them from a secret classification point of view than using UFODAB. I don't think they would distinguish.
Got it. Okay, so you're saying they would be careful and make sure it was not visible to those means.
Oh yeah, they wouldn't do that to begin with.
Right. Okay, that makes sense. So just my last question. Going forward, things are shifting in this world. You're getting more attention because of the TV show. What's the name of the TV show again? Expedition
Well,
X?
there's several things. And by the way, if you want to check that out on the website, they have a news tab. And it has a long list of publicity that UFODAP's gotten that lists what I just mentioned, those few shows.
Right.
There's also recently been the full-length motion picture, the documentary about the UAPX expedition to Catalina,
Yeah,
which is now, by the way, just became available to watch for free.
I think it's called Tear in the Sky, right?
A Tear in the Sky, yeah.
Yeah, yeah.
And in fact, this release that just came out was modified because to give me a credit finally. It didn't originally. Unfortunately,
I'm glad they gave you a credit. It did bother, I watched that movie, it bothered me because as a scientist, it really bothered me that they walked in front of the camera several times when the camera was fixed on the.
Yeah, well,
Why?
the fact is that they're a great group of guys, and I'm working with them now to analyze the voluminous data that came out
This
of
is UAPX.
UAPX.
Yeah, they're a great group of guys, I agree. But even they will admit, like, they did not have the great data collection.
Right. And unfortunately, every time they would in the movie, they would go up to this tripod mounted thing,
Yeah,
which is like what I just showed you in the video, and they would never mention what it was or where it came from.
I know. And you're like, but wait, here's
No,
the.
wait. But I think they mention it up to obscurely later when they sit around talking about the really important event it captured, the
Yeah,
hole in the clouds,
yeah.
right?
But they
So
were focused on the event, I understand.
yeah, that event is what they're most focused on, and so corresponding the data from the UFODAP video with data from the IR array of IR cameras and from the Cosmic Watch device.
Yeah.
And that's what the scientific papers will hopefully be on this year that Matt is working on.
I hope so. I think it's very hard to get timestamps on those things.
Yeah.
So they may need to record again. Maybe they did record again.
Yeah.
Maybe they.
I mean, I kind of take it, to me, it was an important first step. I don't think the movie was all that good from a movie making point of view, but it was groundbreaking in that it was the first time someone wanted to document citizen scientists, so to speak, using equipment to proactively collect data before it happened.
Yeah, I agree. That's what was groundbreaking about it. Absolutely. And that's why it's
That-
important.
right.
Yep.
That is the whole huge thing that
Yeah.
Galileo and me and others are doing now for the first time. We're not waiting, or we're not just, oh, somebody said they saw something, we'll talk to them like MUFON does, which is wonderful, but it's not the way to do science.
Well, but that reminds me of a question about your data. Let's say you're using one of these mission control systems. Does the mission control also put timestamps on all the data so you can line them up?
Yeah, constantly.
That's so critical.
Oh yeah.
Because I know the UAPX guys were individually lining them up.
Oh yeah, no, if you look at the videos from any of the videos I have online or anything, embedded in the video is the time and date and time, the type of camera and everything. In fact, all the parameters used to generate, a lot of parameters to set up the system are captured with the data.
Yeah, that's so important.
File is kept with it.
Yeah.
Should there be a need to go back and say, now, what parameters had I set when this was being done and all that stuff?
Yeah.
But,
Yeah, that's going to help them going forward. That's going to be really important. So what are your hopes and fears going into the future? So if you imagine the future of your organization, the future of UFO data collection, like what is your rosiest future and what is your except if this happens?
Well, a couple of things. The main thing is that there, one way or another, whether it's through UFO data or something I do or someone else does, there's a way that I can promulgate through all the 40 installations, and there will be more, of people all over the world. They're everywhere from Rio de Janeiro in Australia to Washington State, and across the country, who want that data to go someplace. And to me, having a mechanism, the original thought of someplace they could upload stuff and say, gee, this looks interesting, what do you think, is a huge incentive to the whole community to want to use their equipment.
Mm-hmm.
But now, it's like you want to be an expert baker, but there's nobody who ever wants to eat what you make. It's not much of an incentive to ever make anything. Right?
Yeah.
So that is a big deal. The other thing from my point of view is that I'll continue working the way, and I treat this like a job. I mean, I've been retired for almost 10 years or so, and this is what I do many hours every day of the week, to mostly software development, which is, this is like more than 60,000 lines of code. I have to maintain and fix and bug fix and add features and so on, and keep moving with it and work on the developments I mentioned. to enhance this, in particular, listening to the user base, to the SCU, and so on, to say, well, gee, what direction should that take? How can it be improved? And also from a global perspective, how can I make it ever easier for users to use it? It's the whole software suite. It's not like using a toaster. It's just not. This is for the technical or scientific minded a bit. They can't just expect to plug in a camera, turn it on, you're done. Because what could happen is, it might just record continuously, keep triggering on everything, because it's too sensitive, or maybe not enough.
But wait, does this tie into your hope or your fear? So your hope seems to be you want some receiving end of this data. So one receiving end would be SCU, to develop out SCU, so it has
They plan to do, as far as I know.
another is NASA potentially, right?
NASA, maybe even Galileo. Maybe
Yeah.
Galileo would look, if they were, open-minded about it, they might say, well, we're going to do our own thing, and that's important, but we also want to put your systems with maybe sensors tailored to our specifications or adjusted to them or something. And
Or just have scientists analyze your data regardless.
I want to put those in many places, and they don't have anything like an MSDAU.
Yeah.
So
Yeah.
the MSDAUs can stand. There's no need in UFODAP to even have a camera.
Right.
It can stand alone. You can use mission control and have 6 MSDAUs and spread around an area and be collecting data from nothing but them. And at the center of that area, maybe there's a Galileo telescope.
And so if that's your hope, what is your fear? What do you think gets in the way of that?
Well, one of the biggest things is, and I know I think people in SCU are very well aware of this, what if after all the effort that Galileo's put into what they're doing, they don't come up with anything? And whereas I'm feared of that, because I'm not sure yet they know what they're doing completely. But if they field one or more cameras and nothing really is collected of scientific value, or worse, that they say, well, I can explain everything, and all of a sudden they say, we're done. We figured out there's nothing here, folks. And
it's a
we
null
spent
result.
the money, we wrote our papers, and we're done. And which, that would, if they ever did that, that'd be a big signal to the same big international public who follows what they're doing, to believe that, well, they tried instrumentation, it didn't work, so what's the difference?
That has to do with science education. So the recognition that a null result, you can't conclude anything from a null result because you don't know if you've done the experiment correctly. You need a positive control. Yeah. And so that's science education. But I understand your fear because we don't have great science education. So how would people even know that? Right.
And this is why it's so important that we all get our heads together.
Yeah.
And try stuff. Putting out, whether it's a Galileo telescope or a UFODAP camera or MSD or something, so that's like launching a satellite to the unknown. Yeah. You figured out, you took your best guess at what sensors you need, you sent it out into space, approximately in a location you think it might collect something. You don't know what you're going to get. Yeah. Yeah. That makes sense. We do need to get our heads together on this. So I guess one final question I had, wait, or did we cover it? No, I still have the question. Do you have a personal opinion about whether UFOs represents, like, what's your theory? Do you have a personal opinion? I've always been a kind of a nuts and bolts guy.
So you think that they're 3D objects, but do you have an idea of where they're from? Are they from Earth? Not at all, no. I don't want to preempt any science, so that's the whole point of the exercise, but I kind of don't think they're from Earth. I don't think that makes any sense to me, especially from a nuts and bolts perspective. I think all the technical signatures that we have that have been reported through hundreds of thousands of cases now, there's more than 200,000 cases in MUFON, let alone with QFOS and NICAP and all that and all that. That's people are reporting what they see and feel and hear and have been affected medically by. Those aren't effects of clouds and things that aren't real. So I'm taking a guess. I'm saying I think that they are real, and I build equipment that could potentially capture those technical signatures, and we're going to see if that's effective. Same thing. Galileo is doing the same thing. Yeah. And others are trying the similar concept. So
we'll see, but I
Well,
think
there's a difference. There's a difference. Sorry to interrupt. This is important. Galileo project has the analysis and the sensors in one organization. You're saying, I just want to do the sensors and I want to give the analysis to people who know how to do it. I think that's a big difference.
well, in a sense, we're all one part of the same kind of organization. I mean,
Yeah.
you could say Galileo has about, I don't know how many now, 50 people or something,
I think 100.
100 people. You could say that UFODAP has at least 40 or 50 people because of all these sites. If the whole point is if we think of that as I think of it as the UFODAP community, the team UFODAP, in effect. That's the website that all collaborate and share. In fact, another plan I have is to set up a bulletin board where people can collaborate and share all kinds of observations, speculation, tips and techniques of use, and videos and things whatever I can manage to do to all get our that team together to do the best work we can. And as we will get more and more such people as we go along. And the important difference, by the way, is for those 100 people, whatever, they have a budget of $2 million, last I heard. UFODAP has a budget of 0. Yeah, or you could say those individuals put out their own good money. Some of them spent, it's thousands of dollars in some cases. Some spent $95 to get OTDAU. Maybe they just put a USB camera on it and stuck it in the window. That's all you have to do. That's the minimum. Cheap, but effective.
Yeah.
And, it's all valid. So that is our team.
Yeah, Team UFODAP.
Yep.
I like it. Okay, any other comments that you want to make sure you get out before we go? I think it's been a really interesting conversation.
Yeah, and I appreciate very much having this conversation with you and what you're doing. And if when you get a chance to go over this and look through all this stuff on the website, ask me anytime if any questions, I can help with.
Thank you. It's really, your work is amazing and helpful, and it's so wonderful that you're very collaborative. It's just great.
Yeah, that's where it has to be.
That's right.
Nobody can do it alone.
That's right.
It's too big.
Exactly. Okay, thanks, Ron.
All right, thanks very much.